pass the floor to Dimitris.
Great, thank you. So thank you all for being here again for a second day in our training. And so yesterday we saw a few things about generally how we extract texts and make some processing of these texts. They were sort of task agnostic for the most part. If we exclude the sentiment analysis that we did on the second part of the training yesterday. So today we're going to work with some ancient Greek texts, and to do that, we're going to make use of some tools which are specially designed for this, because most things tend to work with English quite well, but when you want to work with other languages, you need the support of some tools that have been created specifically for this purpose. So the first thing that we'll do is we need two things. We need our Google Colab, like we did yesterday. So I have shared the Google Colab, the notebook that, sorry, we have a question?
No, it's just for the participants to tell us what languages they work with.
Okay, great. So we need to use this notebook, and I have shared the notebook, and please go to File, Save a Copy in Drive, so you can make changes in your own version of the notebook. And I'll just wait a bit for the process. And I have also shared a text with which is the life of Alexander, Plutarch's life of Alexander. It's written in ancient Greek, and this is what we'll use to for our text processing and the analysis that we're doing. We'll do a few things with it, and then we'll discuss about them. So please, I want you to download the file locally to your computers, to your computer, because then we will upload it to Google Colab. It's a text file, and I will wait a bit so that everyone is ready. We're going to do is we're going to use CLTK. So we need to install CLTK, which stands for Classical Language Toolkit. This is a library that is created to work with classical texts, not only ancient Greek, but also Latin and other languages. And it will assist us in doing tasks such as tokenization, POS tagging, things that we discussed yesterday. But in this case, we are going to use CLTK, the CLTK library for these tasks, because they are specially designed for this classical language. And in our the first block of code that you see, remember that anything you see with green is comments. It doesn't do anything, even if you delete it. It just, we use it so that we know what the code does, to remind us, or if someone else reads it that doesn't know what it does. And what we're doing is we're going to import the central module, which is NLP from CLTK, to use that for processing texts. In this case, with ancient Greek, So that's why in the last line of the code of this block, we are going to specify that we're using Greek by the part that it says language GRC, and we're going to pass that to an, let's say, an object that we're creating, so we can use it then to perform these processes. So I'm going to run this block. It will take a few moments. So it will also download a few dependencies for CLTK to work. It will take a couple of moments. Of course, the next thing that we're going to do is, first of all, we want to read our file. This time we have a text file. Yesterday we used a CSV file and a PDF file. And text files are a better file type to work with. And what we're doing here is we are opening the file in read mode. That's what R stands for in the code. And we are making sure that the text is read correctly. That's why we specify the encoding, because sometimes things don't work as expected. And so we using the read, we're reading the file and we're passing that to the text. So I'm going to run this block. So oh no, sorry, we forgot to upload the file. So we're going to, in your left in the left part of your screen of the Google Colab notebook, like we did yesterday. I'm sorry, we forgot this part. We're going to upload our file. Hopefully it's in our desktop. And we're using the first one with the arrow facing upwards to
Upload.
Yes, to upload the file. Okay, we are getting a warning about the thing that when the when the runtime is terminated, it won't be saved. We have to make sure to have it saved somewhere if we want. So I'm going to run the block again, and this time it should run okay. So basically what we're going to do now is we're going to use the pipeline that the CLTK provides us. It's basically, we will let that do all the work, and we're going to pass that to the variable doc. Let's call that this way, and I'm going to run this block. And what you're probably getting is a message that asks you whether you want to allow the download of the SpaCy model, which I'm going to press Y and enter for yes. Yes, I want to download this model to Google Colab.
GR Odyssey.
Yes. That's and we also need this a word embedding model. So basically, I'm going to I will press yes again, Y and enter, and I will talk a little bit about until it downloads what these word embedding models are in very simple terms, so that you know why are we downloading these things. So basically, it was we found out about a decade ago that these models were first developed by research groups of Facebook and Google and so on, that we can basically transform texts into vectors, into numerical representations, and we can then perform some basic calculations with them, which allow us to have some sort of semantic and contextual information of these objects. Like, for example, we could make calculations which would, when we talk about in textual terms, should result in such things as a queen is to a woman what a king is to a man. So these types of things, and they were the first, one of the first such revolutions in natural language processing. I mean, the modern revolutions after the classical machine learning algorithms. So now that we all, I hope we are all have downloaded these two things, we're going to move on to tokenization. I think we talked a little bit about tokenization yesterday. We tried to use it in some basic forms, like using spaces to make sure we have something akin to words, but that wasn't exactly accurate. So then we used some more specialized tokenization tools. And this time we will do the same for ancient Greek. And I'm going to run this code. And basically, the reason we're doing that is because when we pass something, a text to a let's say a variable, and then we want to analyze it, it's at first all the text is passed like it as a whole. It isn't considered like we consider it as parts of words and all that. It's just a string, and we have to then split it into meaningful segments, words or punctuation, and so on. So remember that we're basically using, let's say, functions that are ready-made by CLTK. We're just making use of them. We didn't create anything in ourselves. We're just passing that to an, let's say, an object that we're calling tokens. And then we're just printing the first 10 tokens to verify how it's working. And we see that it does split, it seems to split the text fine. And it does recognize the comma, for example. So we can then move to lemmatization. So basically, we talked a little bit about this yesterday. Basically, lemma can be used as a very how can I say it, a neutral form of every word. So this is especially important for languages that have a rich inflection, like ancient Greek, which has many cases. Has a very let's say, sensitive grammatical system, or languages such as German or Russian. And what we're basically getting here is the form that we expect to see on a dictionary. for Greek or ancient Greek, let's talk about ancient Greek and stay there. It's we use the nominative case, and in names, and let's if we run this block, we also aren't creating anything. All this is done in the process that we did earlier, that we passed it to the to CLTK NLP, and in the doc object that we created. Okay, so what we're seeing is that instead of tone, which is an accusative case, we're getting O, which is the nominative case. We also are getting, instead of Alexandru, which is in genitive case, we're getting the nominative case, Alexandros, and so on. So this is very useful in some analysis. We discussed a little bit about it yesterday, and this is an important part in text processing. And what we're going to do next is extract the POS tags for the words along with this with the word, so that we know which one we're talking about. And what we're doing in this part of the code is we're going to create, let's say, an object that we need two things in it. If you see, we need the word that we're working with, and we also need the part of speech for this particular tag. So basically what line 6 does is it iterates in all words in instances in the doc object that we created earlier, and gets these two things, the word and the associated part of speech tag, which tells us if it's a noun or a determiner, and so on. And then we're printing the first 10 instances along with their part of speech tags. So I'm going to run this part, and I'm getting both of these. Keep in mind that this may not work always in 100%, even in English, which there's a lot more research done, and it's kind of easier to work with English text because it doesn't have so much complicated case system. So, and also I have, as you can see, I have provided some explanation of the thing that you see with the 10, how it works. Remember that this is also another way to use comments. So in this case, we have selected the first 10 items because the general syntax is shown in line 17. So, for example, if we want to use the last part, the last 10 words with their POS tags, we're going to the next block. We're going to uncomment it because it's a comment, right? So now that we have uncommented it, we should get the last 10 words along with their POS tag. Like ita, it's an adverb. Yes, of course.
Can you repeat what you said, the prompt? What should we do?
We should uncomment it by delete the first character that you see. So The hashtag, yeah. Yeah, I should have used Instagram language, maybe. So, yes. So we can get the last 10 words along with their POS tags. And remember that I told you earlier about all the analysis already has been passed in our doc object that we created earlier. So in the next part, I'm going to uncomment it as well. And I'm going to run the blog. We're going to see the fifth item in the list, which is Vion, means life, because it talks about Alexander's life. So basically, we're using the fifth item in the list. Remember that the list, it starts with 0. So number 4 is the fifth item that we're getting in the list, along with a lot of information about this string. So we see that it's Vion. The part of speech is noun. We have the lemma, which is Vios. Some other information, dependency relation. We'll talk about it later. We have the features that it's the case that it's accusative, the gender masculine, number singular. Okay. And some of them are missing, like the phonetic transcription. It should use, I guess, the IPA for the linguists of you, those of you who are linguists or know about the international phonetic alphabet. I guess that's what it uses. But this one doesn't have a phonetic transcription. So, do you have any questions before moving on? Anything or anyone who isn't here with us?
Yeah, we have.
Okay.
Susanna?
Yes, hello. One question about the last command, print dog words. Like the object it returns, what type is it? Like, do you know?
It's what type?
Yeah, because I see like you have a lot of information, so I was wondering whether the object of dog words, if you inserted in a variable, what type it would be? Like, would it be a string or?
Yes, it's probably. Let me see. I think we talk about it at some point later. Sorry, and I think so. Yes, but if I recall correctly, we'll talk about it in a minute. So okay, but yes, I think so. Yes, yes. So
you'll come back to that. And
yes.
if still there is a question, Susanna, don't hesitate,
Yes,
and everyone.
because yes, I think it's.
I also have a question /
Okay.
comment.
Okay.
In the block code block under lemmatization, entitled lemmatization. Here you didn't lower anything, and yet you have proper nouns like Alexandros, and everything is lowercase.
Yes, this is probably done in the processing by CLTK main module, which is
choice.
It's
if you can
yes,
guess,
it's probably
maybe you did not create CLTK yourself.
No, I didn't, and I haven't really used it much because I haven't worked much with ancient Greek. But it's part of a normal. It's a normal part of the normalization of text normalization processes that we use. So I assume it's very standard procedure for most tasks. So
even about named entity recognition, where capitalization would be a useful way to.
yeah, that's a very interesting question. I'm not sure. I guess they're trying to predict that sometimes different in different instances would have some would have capitalized the first letter, some would not. So maybe they're trying to predict that. I'm not entirely sure, of course, but this is just a guess. I could be wrong. And so so the next thing that we're doing is we are going to see some dependencies. So this is basically a way to extract some syntactic information about the structure of the sentences. Well, I have a linguistics background and actually a syntax background, but my background is basically in generative syntax. So we haven't used dependency grammar much, but the main idea is that the root of these structures is the verb, the finite form of the verb of the sentence, and things are related to each other through some type of relations, and some of them are related to the verb, and some are related to dependencies of the verb. So this is the main idea. Like I said, I have mostly experience in generative syntax, but if some of you have worked with dependency grammars, I'd be happy to find out more about it. So what we're going to do here is we will import some modules, the dependency tree, first of all, because it's a tree structure similar to generative syntax trees. But like we said, they are more dependency related. And then we're going to use pprint, which will help us print something that looks like a tree, let's say, in the text. So again, we're working with words. So we're going to extract the words in the first sentence as an example to work with this tree structure. And that's what line 9 basically does. We're asking to iterate in the words in the sentences in the doc object that we created. And we're using the first, of course, sentence in this case. So then what we're doing now is we are going to create an object for this tree, and we're naming it a tree in line 15. So we're going to send there our text, basically. Then we are going to print it, and we're using two forms because the first one basically is a structured way, but it's not so readable. And then we're going to try to imitate something that looks more like a tree. And I'm going to run this block, and so we can see the relations in the first part, because remember we asked to output two things. which gives us the dependencies of the different things along with the POS tags. For example, Vion and Ton. So we get the determiner, which is the relations. It shows us the relation between the Vion and which is life, and the Ton, which is the determinant. And we can see below the dependency tree. So the root is proerumen. Like I said, basically the root is usually the finite form of the verb. In this case, the root of the sentences, and different things are dependent on it that have other dependencies. And if anyone in the comments maybe, or anyone here has worked with dependency grammars, I'd be happy to hear any input you may have before moving on. No? Or any comments?
The only comment is that universal dependencies models exist for almost every spoken language. I mean, you're a generative syntax person,
Yes.
but I think this has taken root, and I wonder, and I think the answer to that, I predict it will be yes, but I think there would be another way to visualize this as a normal tree,
Yes.
you know,
Yes,
with
yes.
the root and the
Yes.
branches
Yes.
using Python
Should
code.
be. It,
May I
yes, of
ask
course.
something?
Yes.
So here, in this part, the ifu κατελήθη goes to the root of προαιρούμεν.
That's something you should probably ask someone who is more familiar with with dependency grammars.
I'm wondering because
But
as I see, this is correct. I mean, so far, if you go until here, but because I've worked with trees, and this reminds me a lot with syntax trees and stuff. But this thing does not go to the. It's not an adverb that goes to προαιρούμεν. It goes to Caesar. Ifu
Yes.
κατελήθη Πομπίος.
yes,
So I think that's. I don't know if it's a mistake.
it's probably these things. I know that they don't work 100%
Yeah.
always, so it's expected to have some sort of these things do happen
Okay.
sometimes. So I don't think dependency grammar would be any exception to that. And if I assume they have worked they have trained such models in the same way that they have, since we use the NLTK again library, so the CLTK, sorry.
Yeah.
So it's probably something to be expected.
And we have one more question from the
Great.
chat. I wonder if it works well with imperative, because in modern Greek it does not.
Yes, so CLTK, I don't think. I have never worked with CLTK for modern Greek, and but I'm pretty sure it wouldn't work as well. I have tried to work the opposite direction using tools for modern Greek, for ancient Greek, and they don't work so well. So I assume it will also be the same thing in when you try to do the opposite thing. So
There was a colleague yesterday, sorry, I can't remember their name, who works with Old French, and it would be useful to see if CLTK works with Old French.
yeah, it has they have the specifications on the, of course, in the documentation and so on. They have the list of languages. I'm not sure if they work for Old French, so that's something to So I'm not really sure if even if NLTK or whatever else tools work as well in modern Greek, for example, in the case of imperative that you're asking, because like I said, the all of this work that I have done with syntax in modern Greek involves a specific framework, which is the generative Chomskyan tradition, and it makes a lot of assumptions. So I'm not really sure. We didn't use the dependency syntax much, but I can tell you that NLTK can work with generative syntax and also other tools, even logic programming languages such as Prolog and all this more traditional. They can work pretty well with generative syntax, and I expect them to work with dependency grammars as well, but I don't know that for sure. And I'm going to move on to feature extraction. So basically, let's say we talked a little bit about that we are going to get some sort of object which has a lot of information about what it is that we're working with, and that's what we're going to do now. We're going to run the next block, and I'm going to talk a bit about what these features are. So basically, we are creating a table with these types of features, and they can be, for example, we'll see it on the next block, and I'm going to run the next block as well to see what types of information we are going to get for the words that we're going to use. So some of them I can tell you what they are. Some of them I'm not really sure what they are, or even if they are applied to ancient Greek, or they are made for other classical languages who have different grammars. But basically, you can get the lemma, the embeddings that we discussed earlier about it in the beginning of the session. The is stop part, I assume that it's whether it's a stop word or not. We discussed about stop words yesterday, but for those of you who weren't here yesterday, the main idea is basically the words that are function words that we use often, and they have not so much content, like the article the and on and so on. So we're getting other piece of information such as part of speech, the case, the gender, the animacy. I'm not sure if that applies to Greek at all, but maybe it does for other languages. The number, the definiteness, the mood, aspect, voice, person. It has a lot of information, and
Well, it's not only specific linguistic features.
sorry?
So it's also domain dependent. It's not only linguistic features. For example, about governor, the definiteness, I don't know what it means. What about governor animacy and so on?
Yes.
You can find it.
Yes.
Is it also possible to parameterize with using an ontology, for example?
Yes, it basically, if I understood correctly, it also uses some since it also has the information that we talked about earlier in the dependencies and so on. It can also extract information about the governor, let's say, word that it uses. For example, if you have an object and the governor, I assume, is a verb, you can also extract some information if they are available about this object as well, the verb.
Yes, but about polarity, what does it mean?
I assume it could be, but I'm not really sure. What comes to mind really is maybe it has to do with the things that we discussed earlier about yesterday. Possibly, I'm not sure. I'm not really sure if it's the positive and negative and so on. I'm not really sure. I have to really read the documentation of the CLTK because it has a lot of things. So but I assume some of them are, for example, it has the governor politeness or something. So has a lot of extra things that I'm not really sure of how they work, but we can check that out in the documentation, on even in the break. So.
Yeah, it's positive or negative.
So yes, it has to do with the sentiment that we discussed yesterday. It's sentiment analysis. It uses some sort of possibly some basic sentiment classification um, task. If it's not all things, of course, have a positive or negative polarity. So basically, what the next block does is just to check whether we have the same number of words and the sets of features that we extracted. That will help us see whether our program works correctly. Because if the number is different, something is probably off. So I'm going to run this block and hopefully they are the same number. We have the name, the same feature instances as well as tokens, which is basically words, what I mean. And so we're going to use in the last thing that we're going to do, and then we can have some sort of break or a discussion first, since we have some time. We're going to get a token, a word, the fifth one, to check all the information it has provided for us. So we are going to use the pretty print that we imported earlier for to read it better. And we're going to get the feature name, the fifth element of our list, let's say, along with the list of features. And when we run this block, we can see all of these things that we discussed earlier. The string that we're talking about is vion, which is the accusative of vios, which is life. And we're going to see the array that of the embedding. Remember that we talked about it. It's basically it's a set of numbers that we can locate somewhere in space, and then we can make different types of comparisons and calculations based on this number to perform tasks such as the one that I talked about earlier. It's not a stop word, it's false. I'm not sure why it has lemma 2 times, and it says none. I don't know that. The part of speech is noun, and it gives us the rest of the information that we talked about earlier. For example, the case, the gender, the number, and then we get some information about the governing word, which it's a noun in accusative case, and singular, it's a masculine gender. And so I'm going to put a full stop here, and I don't know if you want to ask something.
Open the floor to questions or maybe issues. I don't know. There is a colleague also from China. Did you happen to face the same issue or an issue with the ancient Greek? Kindly unmute yourselves or use the chat box, please. If there are no questions or issues, we can have the break now, and maybe
Yeah.
If you're all okay, we can have a 15-minute break until 12:45.
There is one question.
There is one question. Yes, what possible uses do you suggest for dependencies, from Anna Maria Galanaki?
Okay. That's a great question. What I would do, because I do not really have an answer right now, I would try to check for example, to check the literature about it, what they use it. For example, Maria Papadopoulou earlier mentioned that it's all over, so maybe you can suggest some sort of uses for for dependency grammars.
No, and I'm not really a fan of dependency grammar. And all the syntax, we focus here on TALOS, we focus on semantic annotation, Rachel's PhD, and also we work with ontology, so we focus on the semantics. Of course, these pipelines provide you with tools in order to provide tags to the elements of your text, the words, let's say. That pertain to morphology and syntax first, but no, I wouldn't. I'm not the expert on that. But I know that universal dependencies are big with ancient Greek. So all of Perseus' texts, for example, and more, because there's also another group, I think from the north of Europe, Nordic group that has done work on ancient Greek, among other ancient languages.
Well, I think the main thing with these models, like for example, the same I would say about generative syntax, which, like I said, my background was in generative syntax. It's basically to provide some sort of formalization for some sort of formal system to analyze structures that are more language independent. You can assume some sort of, for example, if you compare different languages, phenomena in different languages, you can assume some sort of a semantic meaning, a meaning that it's independent of the of the specific language that you're working with, but this, I know that this makes more sense for the
Sorry.
generative
Yeah,
syntax.
you sound like a generative syntax person
Yes.
because you assume that there are Catholica, Universalia,
Yes.
Universalia, whereas I don't know if any colleagues come from the relativist
Yes.
group, trying, not trying to uncover
Yes,
any
that's
universal
true. And
features, but yeah, I
that's true.
believe in, I mean,
Of course.
I don't belong to any of these groups because I'm not a linguist, luckily, so I don't have to choose.
So yes, it's also a thing because a lot of these models were created in English, and that's a thing because, for example, if Chomsky was I don't know Korean, for example, maybe they would have
Exactly.
different assumptions about the
Exactly.
nature of their language.
I don't know about Korean, but I think about Chinese two native Chinese, I think, in the people in the group. There are in the dictionary, there are some words that are not assigned a part of speech. They don't have a part of speech. I mean, part of speech is also an English or a Western.
Yes, yes.
I'm afraid it all goes back to Aristotle, so the Greeks are also to blame. But yes, it's a Western kind. So it's maybe culturally related.
Maybe, for example, if in the case of Chinese, for example, maybe if the whole thing started in China, they would have different assumptions, for example, about the importance of tones, because we know that
Yeah,
Chinese has all these different accents.
yeah.
Like ancient Greek also had this, but not the same accents, of course, but we know that they had some importance. That's what these all markings are. They are not put there for beauty standards. Maybe they would have some different assumptions about the nature of the language. So I think we can start the second part of the training session. So this basically we will use two different notebooks this time. The first one will just work with UGARIT for text alignment, and I have sent you the link for the notebook. It's on the chat. So please open it in your browser and go to File, save a copy in Drive, so you can apply any changes. Wait, ναι, μπορεί να μην στο ανοίγει. Αν δεν έχω κάνει, για κάτσε λίγο. Είναι restricted, γι' αυτό μάλλον. Οκ. Για κάτσε να το ξαναδούμε. So, please try again with the link because so now it should open now. Okay. And go to File, make a copy. Save a copy in Drive. So I'll just wait a minute or two for
So
everyone to catch up.
participants have to download the file titled the UGARIT.
No, they don't download anything. Just
Sorry,
they'll
they
copy. They'll
Let's
just
open a
open
copy, yes.
it, yeah, and
Sorry.
make a copy.
Download from the chat, I mean, or
Yes,
open it,
okay,
yeah.
okay, yeah. So basically, what this tool does is it performs some sort of text alignment. So if you have a Greek, in this case, we're going to work with Greek, ancient Greek, and an English version of the text, it should align the parts, the correct parts. So it's that isn't as trivial as it sounds, because different languages have different ways to encode different things, such as negation. So it's not the same to use, for example, if you take don't, for example, in English, and try to translate that to some other language, such as Greek or French. And you see that in any text, there's not always one-to-one equivalence to everything. So basically, what we're trying to do with this is try to align as good as we can these texts, which are essentially the same meaning in different languages. And in this case, we're working with ancient Greek and English. So first of all, we're going to install a few things. Transformers library. I already mentioned that transformers refers to the architecture of these models, LLMs. A lot of the LLMs have these types of this type of architecture behind, and we also need to import a few things. And once this is installed, so we need to install the auto model and the auto tokenizer. So these two, let's say, auto model is a class to load a pre-trained model. So these are models that are already trained for us to use. Someone else has already done the work for us. And we also need the auto tokenizer to use with the model, the chosen pre-trained model that we're going to use. So we also see two more imports, which is Torch is we're going to use it to handle tensors. Think of it like arrays. And we also use the cosine distance for to measure the difference between those vectors. So I'm going to...
Sorry, because
Yes?
we assume no background. If
Yeah.
you could say just a few words about cosine distance and what was the other one? Tensors? No. Or PyTorch? No. Another term that we use. Maybe yes, PyTorch.
Yes, it's a library to handle this. Remember that we talked earlier about how we need to transform the texts, the textual data, into some sort of numerical representations that are that we can then put that in space. Let's say in an n-dimensional space. So we're going to use, in simple terms, of course, let's say we want to compare two different texts. So if these arrays align closely, they are going to be more similar. So in this case, this thing, cosine distance, this is what it basically does. We're going to use it to measure the angle, the difference between these two vectors. So if one arrow is pointing on one direction and the other on the completely opposite, they are kind of dissimilar. I'm trying to explain it like as good as I can. I'm sorry if I'm not doing a really good job, but so I'm going to run this block, and so now if we can move to the next part. So basically what we want to do here is specify the model that we're using, because we did install transformers and we import the auto model and auto tokenizer, but we haven't specified which types of models that we're going to use. So the model that we're going to use is the alignment for the Greek text. Okay, so that's the first thing that we're going to specify. The model name is going to be the UGARIT jersey alignment, because that's what we want to do. And we also want to specify our the tokenizer that we're going to work with. Okay, so we basically have two things, the model and the tokenizer. And we're going to pass to these, let's say, variables our own, our model, the model that we're going to use. So we're using a pre-trained model, and I have, as you can see, I have two different types of, two different examples of ancient Greek. So we're going to see how well they align. But I have commented the first one, the children play one, because it's too easy. And I'm going to use the second one, which is a longer sentence, which is the king presented gifts to his soldiers in the battle, and the equivalent Greek source text. And what we're doing next is we are using the models to tokenize both the source and the target text. So we are also, yes, I'm going to talk a little bit about because we're going to see them later, about the thing about special tokens. So these LLMs, for those who don't, you don't have to have any background to it. So it has a lot of, it has some special tokens, like at the beginning of a sentence and so on. So we have set it in true because we do want to have them as well in our analysis. So these models were trained from the beginning to assume some special characters, some special tokens, because the first of them were actually trained to perform the following. The thing was to, for example, it had a sentence, and it would ask the model to decide which word misses. So, for example, in a sentence like John said that blah blah blah, it would you would cover one word, and you would ask the model to see which one, which word that you have covered, it should put there. So this works with probabilities. These models are trained with in a very large amount of texts. So it would go through all this. I'm using a very simple, of course, way to communicate what I want to say, to decide which is the most likely word to be missing from this from a sentence. So I'm going to run this block, and so this is going to take a few moments. So we're also getting the warning that we're just using a pre-trained model, and that we should probably train the model to use it for because some of the parameters will be set to at basically random. But for our task, we are not going to use we're not going to fine-tune the model. But for the best performance, we should at some point, but we're not going to do it now. We're going to use the pre-trained model. I did say yesterday that sometimes we can ignore these things, or sometimes we would throw things as exceptions, even errors and so on. But we should, of course, document these things and know what these errors are, at least, or the warnings. So what we're going to do next is we're going to inspect the tokens that we have used. Remember that we specified two sentences, a Greek and the equivalent target text. So we have sent that to the tokenizer, and what we basically, when we run the code, and I will explain what the thing does, but let's first talk about when we run the code. So we will run the code, and we're getting some numbers. So remember that we talked about the whole embeddings thing before, but we also see that our tokenizer doesn't really use words, but smaller parts. So LLMs really use that technique to go to the subword level to gain more information. So this is completely normal. It's a normal procedure. So, for example, it will use it's not really absolutely based on morphological analysis, but it could come close for example, using, for those who have a linguistics background, the root or morphemes, okay, if I may use the term. But sometimes it does come close. But these words do use, unless you force it to use words, which is not always usually a good idea, unless you really know what you're doing. You should let it go to the subword level to get more information about what it is that you're going to do. So,
can I interrupt?
Yes,
Just
sure.
The king presented. Okay,
Yes.
what we learn at school about English is, ed,
Yes.
right?
Yes. Yes.
So here, this chunk seems a little bit strange to me.
Yes, it is strange, but this has to do with the training of the model, which is we didn't train the model, but it should provide, for example, that should have been the best, the most informative way to use this segment in a statistically based approach. Of course, it's not a morpheme. It would be expected to have the ED together, but who knows why this? Yeah. Yes, but it's also some of these tokenization algorithms work with are on multilingual texts, and maybe that has to do with it. There are LLMs that are multilingual. They're not for a specific language only. So maybe it has to do with that as well. So what we're going to do is let's just get the embeddings in the next part, and so we won't use any backpropagation because we're not training a model. And what we want to do is we want to have the best efficiency for the thing that we are doing. So
not many people maybe have understood what back gradients are and what back
so,
propagation is.
yes, basically, okay. The thing is that this I'm going again to be very fast in this. The main idea is it all works. For example, consider that you're trying to find the best way to go down through a slope. So you're going from the top level to the next, always the next the lower level that you have below. So that's basically the algorithmic way to work with the descending this what it is. So backpropagation, it's when you go back and apply changes to previous steps in that you did. I know that this may not make much sense, but sometimes some things are hard to explain in such a short time. In a way that
I think you're doing an excellent job for all of these people who already have some experience with Python, and even for people who are experiencing it now. Maybe when you have more exposure, you will understand that these are perfectly valid, simplified explanations.
So I would suggest, because now we don't really have the time, it would take a lot of time to do it. If you are interested in this part, because it's a bit hard for me to elaborate, to Google gradient descent. It's it's the starting point basically for most of these things, and the neural networks and all that. It's good to have some knowledge of what it is and how it works. So now I'm going to move to the next block, and we see a lot of things happening here. So at first, we're going to loop over its token, and their embeddings, and to decode the embedding into the original text form, because we also want to be able to compare it in a way that we understand, if that makes sense. So basically, then we're going to print this for reference. We're going to see then what I mean when we run the code. So we are going to start to initialize a list to store the similarities. And then we're going to basically do the same in the target text. In the for the to get the embeddings for also the English version of the English part of our program, let's say. So what then we're doing is we're going to the absolute similarity, of course, is 1. So we're going to subtract the amount that the distance is when the distance is larger than that. We're going to subtract this part, and then we are going to add this to the similarities list. We're going to append it in the empty list that we created earlier. So this may remind you the way that we worked yesterday in NLTK, in a lot of in most of the tasks that we did in the first part of the tutorial, the training. So we finally want the best match in this when we compare these two things, and then we're printing this, and if we run this block, we're going to see now how well it works or not. So the root, let's call it root. It's not really, which is from the king in Greek. It has a very high alignment with the king, which is expected, as well as the next parts, which they come from the word Vasilevs. So it aligns with the king with a very high score. Then we have the segments of the next part that align within. Let's see what else. So
best alignment is the full stop.
Yes,
One.
but these ones with 0.993 is very high alignment. But not everything aligns correctly. For example, let's see. I saw somewhere something, or maybe you can help me.
We're looking for low scores. Huh?
Yeah, no, or misalignments, like, or maybe I don't remember correctly.
Yeah, I mean, his strat for Stratiotes best alignment in with scores.
Yeah,
0.9,
that's great. That's some. I remember when I first ran this part. I remember that it had a few things that were really, let's say, questionable. Not really.
Yeah.
So this we have to always remember that these are they work with probabilities, and they don't work perfectly, of course, but so most things align pretty well with yes, but with some exceptions, of course. So we're then going to see the UGARIT Flare, which is for named entity recognition, which is another notebook. So in this part, we're going to use named entity recognition, which basically is a way to automatically extract information about entities, such as the locations or organizations or persons or other categories. So in this case, we'll work with both examples, simple examples, but we'll also use the file that we downloaded earlier to have a full text to work with, which we will break it into sentences to get the entities at the end of the training session. So I have to get back to Luisa as well for the part with the encoding because we will have to use the same.
Yeah.
But even if we don't have time, we can do it afterwards.
Yeah, sure.
Or we can
Yeah.
or we can arrange a Zoom just.
Yeah,
to-
don't worry.
to-
We'll
okay.
help Luisa because we're working with Luisa and her master students on comparative ancient China, ancient Greece. So it will be good to be able to upload ancient Greek text. But
Okay, so
they will, all of us, we will reuse the Plutarch's Alexander, right?
yes, we're going to use this file. But first of all, we're going to, of course, we're going to install Flare and transformers that we also used earlier. So these are again pre-trained models, and we're going to use them for our specific needs. We aren't really we're just working with the tools that are provided to us. I'm going to run this block of code to get Flare and transformers. So in the comments, I have used some information about what these things do, but we also talked about it earlier. So I'm not going. Now we need to load the model that we're going to use for the named entity recognition. The first thing that we want to do is to import sentence, which is basically we need it to make objects that can be used by Flare to work with these things that we want to work, because we want to have some sort of tokenizing and annotation to say that this thing here is that, and this person is a person. Maria is a person, or Dimitris is a person. So we need this this class to do that type of work, and we also need the sequence tagger, because this type of sequences, we need it to label these things that we want to label. And we aren't really doing anything other than specifying the model that we're going to use, which is the Greek version of this model. And we're going to pass that to the tagger. So I'm going to run this this part. And this should also take just a little time. These models tend to be a bit large, so it's only natural. Hopefully someday things will be better in the way that we will have more efficient ways to work with so much data. And it's also important for the environment. I don't know if you have heard about it, but these models take a lot of processing power, and it's not so good for for the environment. So there's a lot of discussions of how that hopefully will be resolved in the future by making more efficient models. So,
but you're using an eco-friendly way to minimize
hopefully,
energy,
yeah, hopefully,
the black screen.
yeah, hopefully. So we're going to, before using our text, the text file that we have, we're going to use a simple example. And basically, we have a sentence which is, it says that, I'm going to say it in English for those who aren't, that Tantalos was a king of Lydia, which is in modern Asia Minor. So we expect this thing to give us, to annotate, let's say, if I may use the term, what Tantalos is a person, should be a person. And we also want to have Lydias tagged. It's a genitive case, but never mind. It's a location. So we expect this part also to be tagged. And remember that we also want to see that. It's one thing to do something, but we have to, most of the time, explicitly ask our code to show us what it did. So that's the point of printing also these things. And remember that I'm not giving much details because we're using basically, let's say, ready-made objects for us, and we're just passing to them our text. We're only creating some variable for them to work. So when I run this code, I get that indeed it can recognize these two things in the sentence, both the person and the location. But what I want to do next is to use a more complicated example, because the one we used above was kind of a simple sentence. So the next one is a larger sentence, and it talks about Alexander. So the ones who are from the classics department can maybe tell me more about this part. What is it about? And
Alexander's family tree,
yes.
genealogy.
So we can see if we run the block that it should recognize.
And the romance between Philip and between his parents. Sorry.
And it seems to recognize, but we have to check if it recognizes everything and if it does in a correct manner. For example, I'm not sure what the last word is about. It has classified it as miscellaneous, the orphanage. I don't know why it did that. So if any of you has...
Also, if I may interrupt.
Yes, of course.
Also, Carano is not a location, it's a person. So...
Yes. So it's important to always check because, as you can see, it doesn't work 100%. And of course, let's see if there are others.
And
maybe.
expertise in Hellenistic history is very much, very useful in this case.
Yes.
And also miscellaneous, I don't know why this tag is...
Even exists.
No, I mean, it's useful to say that it's not it does not be, it's not a person, it's not a location, it's not org. Also, this, I have a problem with this tag org, organization,
Yes,
which is, you know, not one person, but more people.
yes, yes. Of course, this may make
Modern.
sense in, yes, but
In modern languages, maybe, but for ancient cultures,
also it doesn't recognize the last one. Τον αδερφό να Harry. Ναι, it doesn't even.
And I think Olympiad too.
also, yes.
Practice allocation.
Yes.
Yeah.
It refers to
Where is it?
Mm.
Story. It's
It's
where is it?
Alexander's mother. The penultimate, the one but last, before Orphanis.
It's a location, but it has misclassified it. Maybe, presumably because it's also, I don't know what type of training they used, but maybe it has used also modern Greek texts for for the Greek city.
I think,
maybe.
sorry.
Yeah.
No, you go first.
No.
I think it's the cause of dative that perhaps gives it the
Oh,
thought
it
that
could be.
it's supposed to be a
Yes,
location.
it could be.
Interestingly, you said thought.
It's
Mhm.
not.
Anyway,
Yes,
Rachel,
please.
This model is trained on the Odyssey, some, I think, Xenophon, some pseudo, it might be Thucydides too. I know Pseudo-Demosthenes is the one that I provided for this, and then a few others, but it's maybe because this is Hellenistic, it's not trained on Hellenistic Greek.
thank you
Yes,
for this.
this is
Rachel.
very
That's
very
very
important
important.
because I didn't really know it, so it's
And also,
it
we're
makes
thankful
sense.
to all these people who've
Yeah.
created all these libraries and all these models.
Yes, of course.
Computer scientists, classical scholars, digital humans, we're grateful to all those people.
We had a raised hand, Susanna, I think.
Okay.
Yes,
Uh,
thank you. I have a question. So you said you always have to check the correctness. So if you have to do that, then I wonder what is the added value, where you save time, or what is the workflow in real life projects? Like how does it help a researcher in real life if they have to check everything?
Okay, that's really a great question, but these things work best when you have in mind larger scale projects. For example, if I have to do that, the named entity recognition on one sentence, I will not use, of course, such tools. I will just do it myself. Or maybe if I'm not a classist, so I would ask someone who is more qualified to do the job. And of course that makes sense. But if you want to do that with, for example, I don't know, in let's say in this case in Life of Alexander, which is a larger text. So that can save you a lot of time because you'll see that we're going to do it afterwards. We are going to save the NER tags locally, and then someone could only check how well it performs. So it could save you in similar tasks for me, for my experience. I would say it does about 80% of the job, and it's very helpful to have that. But you also have to keep in mind that you will miss some things in larger texts. You will not get, even if you do it by yourself, it's natural that you'll miss something. If you're working with in a bigger project that you're using thousands or tens of thousands or even larger, because you know that Greek has a very long tradition of written texts, and then it gets a bit more intimidating to work with all this data. And nobody wants to have things that are missing in their data, but it is expected to happen. You can get, it's easier to get from 90% to 99%, but harder to get from 99% to 99.99999%, if that makes sense. I don't know if I answered.
Yeah,
Question,
perfectly. Thank you.
So, and this is the part that we're going to use our TXT file like we did before. So a lot of things happen here, but we're going to get into details about it later. First, we're going to upload the file like we did before by going to the left side in files and using the same things that we did before to upload from our computer this the TXT file, the text file. I hope you haven't deleted it. If someone has already, please let me know so I can share it again maybe. So we're going to ignore the warning that it's thank you. Okay, I'll just wait a little bit.
While waiting, I will go back to Susanna's question and your answer and Rachel's comment and my comment then after Rachel's. It's better to provide the model and do the work, even if it's incomplete or it has mistakes, rather than not do anything. And this is the point of doing research in digital classics or digital philology or NLP or digital humanities. Because yes, okay, for one sentence is okay, and the human hand can annotate correctly, but you can't do that for the whole of Life of Alexander or Plutarch or all the texts that we have, and this work has to be done. So
they did write a lot of things. The Greek authors did produce a huge amount of
and I
texts.
think there should be a gentle competition. I don't know how to say it in English. Ευγενική άμυλα, it's in Greek, like to which language is going to be more better documented and better resourced and with better tools. And especially for less spoken ones or heritage languages, ancient languages, medieval languages. I don't know, sign languages.
Yeah, I was actually surprised that these things haven't already been done because it's, I don't know, it was weird for me. I expected that...
when something has not been done or has not been fully done, then it's good for researchers who can fill in the blanks and the void.
Okay, so we're going to see what this part does. This is a bit huge block, but and it will also take some time. So we're just first importing the things that we did earlier. I would suggest that you run the block until I explain everything, because it will take some time, probably about 5 minutes to do all the work. So I'm going to run the code and explain what it does in the meanwhile, so we don't waste any time. So first of all, we are importing the things that we did earlier, nothing special. Except line 4, which we didn't use before. This is basically a library to use regular expressions. This is a way to to handle things such as punctuation marks and regular expressions by itself is it would take many training sessions to explain, and you have to be really a pro to use them correctly in all instances. They can be complicated, but those who are very familiar with older types of more traditional programmers or Linux and so on, they should have some understanding of what it does. So we're using the Tiger again. We're going to use the model that we did earlier because we want to tag these entities. So once again, we're going to, like we did yesterday a lot of the times, we're going to define a function to split our text into sentences. So we're going to use Greek punctuation or new lines for that. And basically what we're going to get in the end is the list of, let's say, sentences. And we're going to join them, all of these, in the list that we're getting in the end. So we're defining our text file, which we have uploaded. And we also need to have an output file, which we're going to name, we're going to use the same name, but we also have in the end the NER to know what it is. And this will be saved on the left part of the screen when the thing is completed. So one thing I forgot to mention is that we're trying to work in a way that each step is very carefully planned and thought, because it's when you want to do something, the thing is that you have to be able to explain it in a way that the program will perform what you want from it. So you have to be able to, step by step, keep in mind of what you want to do next. That's why we're defining the output file even before we open the file that we're working with. We're doing that after, in line 38. But we already know what we want to do. We want to use something as input, our file, our text file. We want to to cut it into sentences. We have to have a strategy of how to do that. And we want to have the entities annotated into our text. But we also don't want to do that on the text, on the file that we uploaded. We want to also keep the original file. So when we want to open our file in read mode, so all of these things must be carefully planned beforehand or during the process. So then we use the sentence class from the Flare. We didn't create it. Remember that we didn't create it. We're just passing to that whatever it is that we have created, the sentences that we have created. And we apply the model. We try to predict what it is that we want to do. Remember, we also didn't create this model, right? So then we want to append we want to add all that to our new file that we have created. So once we have that, we also want to save that to the new file that we have created. So we want that to be in write mode, and we want to write there. That's why we use the write function to write in this file all the sentences along with their tags. So we have it here on our left side. We can then download it if we want, and then we can open it. That's I'm going to, and it's also a text file. And now that's a bit hard to read for. And we're going here. We can see that we can have each sentence along with the number that it has. It's the characters that each sentence has, and we can check then each sentence the texts along with the NER tags. So I can't do that now, of course, for all the sentences because, and here is where the part about the question that was asked earlier about why can't we do it manually? Of course, we have to check everything, but a lot of the work has probably been done. Now, in the best case scenario, we will have a small team. Hopefully, we have enough funding to have a small team and go through all these sentences to check whether the tags make sense. And then we can possibly discuss how well it works or not. So this has to do, of course, a lot with the training. And as mentioned earlier, you mentioned the text that
with these two,
okay.
four notebooks, right?
Okay. Yes. We used first of all we did some basic text extraction and processing using both some custom approaches and also some tools like NLTK. We worked with Greek data, modern Greek data, and we applied. We could see some techniques such as part of speech tags and also frequencies, and we did some very basic visualization. We checked some very basic visualization, and in the second part of yesterday's training, we had some very introduction on sentiment classification, and we did see both machine learning, classical machine learning SVM algorithm, as well as BERT, which is an LLM model, the Greek version, of course, because we had Greek data. And today we worked with ancient Greek data, and it was the first session was about mostly CLTK and its core functionalities, which range from part of speech and feature extraction and word embeddings. We can then, if we can go in more details, we could extract these embeddings for other tasks that we want to work with if we're working with ancient Greek. And after the break, we worked with UGARIT and UGARIT Flair for the last part. I'm going to start from the last, was the one that we did now, the named entity recognition. We did some simple sentence. We had, as an example, we used a simple sentence, and then we tried to apply the whole technique to a whole text file, which was Plutarch's Life of Alexander. And at the first part, we did the alignment, text alignment with the English equivalent translation to see how well it performs on ancient Greek texts.
Okay. If there are no questions, I will invite you to all to give a round of applause to Dimitris, and thank Dimitris.
Thank you.
And don't hesitate to contact us with your questions or ideas, or the reuse of these collab notebooks. And maybe this is a good venue also to advertise the TALOS Open Dataset Award for open data for reusing our open datasets. I put the link, and it's I would like to clarify that all TALOS events and content are free for all, open, and no fees are required. So stay tuned for our next events. Thank you very much.
Thank you.
Submit to our newsletter.